Good evening, all. Um, Welcome to this evening's event, which is being hosted by the Mechanical and Manufacturing Division of Engineers Ireland. But the work is being done by our two speakers. The topic tonight is Additive Manufacturing in Ireland, Landscape and Standards. We first discussed an event like that last year because there are so many bulletins about advances in the sharp end of technology and anecdotal references to medtech companies using additive manufacturing, but we lack an understanding of what the reality on the ground is. All our inquiries to do something about that shortfall in knowledge led us to Paul Quinn, Dr. Paul Quinn, who is present. Paul holds a PhD in metal additive manufacturing from SETU Waterford, where he is also a lecturer and program leader for the mechanical and manufacturing engineering degree there. He was previously responsible for the development of additive manufacturing training programs in the ETBs around Ireland and has assisted Irish companies to adopt additive technologies. Paul is currently the Chief Examiner and World Skills Ireland expert for additive manufacturing. He ran Ireland's first national competition at the RDS last September, and he's going to go to Shanghai with um, the Irish competitor later this year. Barry Cox is a standards development manager for manufacturing and machinery at NSAI. He manages a portfolio of manufacturing committees and he plays an important role in ensuring Ireland has its say in the development of international and European standards for emerging technologies such as additive manufacturing and industrial robots. He collaborates with researchers to facilitate their engagement in the standardization process, and he supports researchers and innovators to help them transform their results into sustainable products and solutions. And so, with all of that, I'll now hand you over to our first speaker, Dr. Paul Quinn.
Thanks, Park. Thank you for the introduction, and good evening, everyone, and thank you for taking time out of your evenings to be with us today. Hopefully, you find this useful and a little bit interesting as to what's going on in the world of additive manufacturing, especially in Ireland, from a point of view of who's using it, what are we using it for, more importantly, why are people using it? So, what's the benefit there? And then we'll hand over to Barry, who will cover the standard side of it, which is really one of the big driving factors to the success in Ireland and to the success of the technology overall. So as Pádraig said, yeah, my name is Paul Quinn. I'm a lecturer and program leader in SETU Waterford. I have a PhD in metal additive manufacturing, so I spent 4.5 years looking at this technology and fairly kind of in depth. That was with Team Research Centre and IMR as well. And then I held a few different roles after that in different areas of consultancy, application design, and training roles across that. As Park mentioned, World Skills is a big part now of what I do. So I have a slide on that, so I'm going to plug that at the end. But yeah, we are currently in training for Shanghai 2026, and I'll talk a little bit more about that as to why that is and why that's so important to in this whole area basically. So bit of an agenda. I'm going to give people an introduction to additive manufacturing. I'll keep it very brief because I could spend hours here talking about that, and I'd like to get to the point of where is Ireland at with it. The growth of additive globally, and then the factors why that's the case, and then in Ireland. So, are we seeing the same level of growth? Is it going to be as successful? All this kind of stuff. I'll have a look then at industry applications. So where are people using this? And through the different roles I've been lucky and fortunate to be able to see how people are using it and help them to try to get it off the ground. The big point then, limitations. So what's going to stop us from getting further and what can we do about that? And then, as I said, I'll talk about our World Skills competition and what's going on with that. I start every lecture, slide, talk that I talk about additive manufacturing with these three little clouds here. So it goes by many different names. You've rapid prototyping, 3D printing, additive manufacturing. And I'm very much guilty of swapping between the three of them without even realizing. So I put these up here to make sure that everyone's on the same page, that if I mention any three of these, I mean the same thing. So rapid prototyping was, the first when the technology was first developed in 1980s. It was the first term that was really coined to be used with it. It was a fast way of prototyping something, but that's the limitation of the technology at the time. As it gained a bit more traction, we moved into 3D printing because people were looking at it going, well, it's my 2D printer, but now I'm, pumping out stuff in three dimensions. And then it kind of gained a bit more traction. And the way I like to put it is that there was applications there and there was materials and there was industries interested in it. So marketing teams grabbed it and said, we have to make this sound really more popular. So additive manufacturing was the right way to go. And it fitted in quite well with our traditional subtractive manufacturing sort of space. So that's where the three come from. They mean the exact same thing. Generally, when you talk to a hobbyist, they do 3D printing. But when you talk to someone that's maybe in an industry area, it's additive manufacturing. So it's just different terms for different spaces, basically there. But that's all I'm trying to get across is that I mean the exact same thing when I say the three of these. Hopefully there's no confusion. Um, I did a little bit. I've done recently done a course on digital education using different tools, and I kind of asked a few different AIs to come up with an image that describes those three things and how they intersect and come across. I thought it was quite fun to put into the presentation today. So you can see a rapid prototype there. It was all about speed of iteration, getting designs out quickly, having people talk about designs and changing over and over again. Generally low volume testing, form, fit, function, that sort of stuff. 3D printing then, we prototyping tools, and these were the tools that we were actually going about. And then our additive manufacturing generally was our industrial side of stuff. So big industry using it, or we have production lines, or we have production facilities ready to roll and bring forward. Um, and over the last few years, particularly in the last, say, 5, 6 years, there's been a massive boom. And the likes of COVID and stuff like that really opened up the space and people got more interested. I have students now that come into me in first year and day one and they're going, oh, I have a 3D printer. And you're kind of like, okay, well, we're not covering that now for a while, but yeah, that's brilliant. So, they're already thinking about it, they're already involved, they're already being aware of this sort of stuff. So, um, it's a really really big benefit to most people, especially getting them to think in an engineering mindset, let's say. So, what is additive manufacturing? So it's a manufacturing process that creates 3D object by depositing materials such as polymers, metals, ceramics, layer by layer based on our digital CAD models. So we take the CAD model, we break it down into slices or chunks, we then put that into a machine, it interprets those chunks, and then produces our object. We currently have 7 different process categories, and there's different processes within each of those categories there, and we have a large range of materials from polymers, metals, and ceramics. In my last role, it became a little bit of a joke that I kept saying that materials unlock our applications. So as we look to get more and more applications for this technology, we need to have a material suite that follows with that as well. So it's all well and good me going after a certain application, a bracket, or whatever the case may be. But if I don't have the material there to actually produce that part or to make that part, it's no good to me at all. So it becomes really important. And we're seeing, our process technologies and our different processes that we use, whether it's FDM or whatever, or SLA or SLS. Generally, the technology in there is, small increments and improving, but our material space is blowing up massively. That's where we're starting to see the big benefits now in terms of people are going, well, now I have a material that I can compare with. Um, Generally, the phrase that the process leverages design freedom to create traditionally difficult to manufacture parts is thrown out there. So parts that we maybe our traditional manufacturing process, injection molding or subtractive machining, um, maybe had constraints with it and we couldn't produce them that way, or we can produce all the features. Additive tends to allow us to maybe unlock them a little bit more. So this is our additive process. Generally, it's referred to having 5 steps. We have a CAD file, so that comes out of SolidWorks or Fusion or Siemens NX or whatever CAD software you're using. We produce in some form of a mesh file that we allow that to pass into our machine software where we assign our different parameters, our temperatures, our laser power, our layer heights, all these different settings that we would do if we were running a CNC machine. We'd be putting in our feeds and speeds and all this kind of stuff. So same idea there. We then pass this code or this machine ready file off to our machine and it prints. And, for the first 10 minutes, we're fixated on it and we watch it. After a couple of years, that kind of fixation becomes a little bit boring, but it's still there and it's nice to see it at the start for sure. What you can guarantee is the second you walk away is when something will go wrong. But anyway, that's by the by for the process. And then we get our final part. And what a lot of people don't talk about is the post-processing that's required. So when you look to buy one of these technologies, no one will ever talk about, the part comes off the machine and you have to do all this stuff. What they normally say is the part comes off the machine and off you go, you're good. But that's a bit of a scam, let's say. Every 3D printed part that comes off will need some form of post-processing. And it's important that we own up to that and we, make that aware, especially when companies or industries are looking to adopt it. They need to be aware of the full process chain because it's sold as single-step manufacturing. You have your CAD file, you put it into this machine, and you get your part. But realistically, additive is still at a stage where it's complementary with subtractive technologies. And we look at metal applications and stuff like that as we go on, you'll see we still need your milling machine, your lathe, your surface finishing tools, whatever the case may be, to get the desired outcome from the object. So it's important that we own up to that. So I always like to add that one in there and say that we still have to do this stuff here. We can maybe design not to have to do it or to limit how much we have to do it, but it does still exist, and it's important that we're aware of all that. Design freedom. Um, Very, very dangerous statement because once you say this, people go off and they kind of design all these weird and wonderful things, and they come back to you go, "I'd like to print this," and you have to go, "Oh, actually, no, I can't do that in that way, or I have to look at it this way, or I have to change things around a little bit." I see it with my students every day. You go off and they come up with these fantastic stuff, and then "Oh, well, we can't print that, or we have to do this to get it to print." So we certainly have a lot more freedom in there if we were comparing it to how we would traditionally design. We're able to use more complex geometries, do stuff like part consolidation, where we take an assembly and we minimize or break down the number of parts that we have to reduce the number of parts in that whole assembly, integrating functions in certain components and parts. We can look at lightweighting. We can put material exactly where it's needed, and we can use different tools to help us with that, to be able to get a little bit more out of the technology. So we're starting to see a bit more beneficial over, I could machine this, but if I 3D printed it in this way, I'd be able to reduce my material use by X amount and see the benefits there as well. We can use conformal cooling for injection molding tools to help to get higher output and throughput from those as well. So having cooling channels that run very close to the mold surfaces and stuff like that. And one of the big benefits of it is we can start to move towards kind of mass customization. So instead of you going in and purchasing a whatever that's in a certain size, a small, medium, or large, let's say being crude, you could get something that's customized exactly to you. And certain industries have been doing this for a long time. So like the hearing aids, a lot of them, I think it's 98% of them across the world at the moment are being 3D printed or additively manufactured. And they're customized. So you take a scan or you take a mold of someone's inner ear, and then that part gets scanned, and then you can digitally produce that model and print off that file. And it means then that those hearing aids fit exactly to that person because everyone's slightly different. And you can see how this could be a massive benefit when we move towards medical implants and stuff like that. So having a customized new hip or knee or shoulder joint or whatever that suits you and it only suits you will, ultimately, hopefully, save on the long run in terms of the potential for issues in after surgery and all this kind of stuff. So that's, where we're starting to hopefully start to move. There's all sorts of issues that are there that we can talk about and explain, but that's where we're starting to see the technology grow and push forwards. When I was in my previous role, kind of doing consultancy on this sort of stuff, I'm looking at from a point of view of, when we're looking at designing components or when we're looking at a part that might suit to be additive manufactured, we tend to put them into these three brackets. And the first one is we've direct part replacement. So we're just basically taking a part that already exists. It's been machined, whatever the case may be, injection molded. It works in that form, but it doesn't fully work. We just take that exact part and we just print it as it is. So the only real freedom we have there is the process that we use. We can maybe change a different process. We move away from one additive process to another additive process. There are we don't like to make many of them because we're not really using the technology for what it's there for. So we have, that was already manufactured a traditional way. It worked perfectly fine that way. So why would we drop it in that case? If we have the ability to adapt it for AM or additive manufacturing, we can start to look at it from, maybe we start making tweaks and changes to make it a little bit more suited to our process. So it will fit into that whole process bracket a little bit more. We're not changing our functionality, we're not changing how it fits, but we might make small design tweaks to get it to sit into that bracket. And it means then that when it goes to be printed, our process is is more suited to the end application. And then the last bracket, and we love this one. This is an additive engineer's dream is to be in this space, is to be able to design something for additive manufacturing. So looking at a part and go, it has to be able to do X, Y, and Z. Now I'm going to go off and design something that does X, Y, and Z. And it might not look anything like what we had originally had in that phase. We can start to look at the functionality of it. Can we improve it? Can we get a little bit more efficiency out of the object? So you can see there's an example of a hydraulic manifold. You have your traditional one, a big block with holes drilled through it, perfectly fine. We could reproduce that, no problem at all. Are we gaining any benefit from them? Probably not. As we move on there, we might be able to remove materials and just print the channels and have little support structures that hold in between it. So we're starting to see that, okay, we're getting a bit more beneficial out of it. We've changed our form ever so slightly, but realistically, our function and our fit hasn't been adjusted at all. But then if I know, what sort of pressures I'm trying to maintain, where I need that fluid to go, where it needs to join up with or whatever, I can look at completely redesigning it and having different internal channels that help to direct different pressures and get different fluid paths and all this kind of stuff. So I can really take advantage of my process and my technology when I go into that space. This is where we want to be with additive manufacturing. The problem is these are very hard to come by. It's very rare you go into a company or you go into an industry and they go, you can do whatever you want. Normally they'll say we have a set of parameters here, and if you want to go changing this, you need to do this, and if you want to go changing this, you need to do this. So it's hard to come across these sort of examples, but they do exist, and we, as engineers, we're able to leverage the design space a little bit more on that. So in terms of how far additive has grown, so 2025 market was worth approximately 30.5 billion US dollars. It's expected to grow $7 billion this year alone. So to grow by by the end of 2026. And it's projected to be at 100, the market's expected to be approximately 170 billion by 2033. So massive growth. But the big issue here is we have different industries and different sectors that are at different points in terms of their adoption and how far they've grown the technology in there. So you have industries like your medical device and aerospace that are quite far along. They've had good success with it. They're at the stage where it's mature. They have a process that operates that are in their early mainstream stage, and they're just running with it then. They're in, nice free flow production ready to go. We've other industries then, construction and oil and gas, that are still at very, very early stages of that whole adoption cycle. Now we're starting to see a move there, of course, in Ireland, and I'll talk about a little bit with construction. We're kind of ahead of the game on that side of stuff, but it is still, at its footholds. What we'd like to see is more of these technologies pushed up that curve into that adolescent or early mainstream stage, because then we have more people using it, we have more applications out there, we have more materials, we have more processes, so it starts to grow the technology massively. Why is it growing? We're starting to see with the technology, and this is true for the last 4 or 5 years. We've moved from prototyping machines, so tools that we have on our desk, and I have one behind me there, small desktop machine that's in the house. People are making prototypes with, and it was the same within the workforce. People had 3D printers there to make a prototype to see, yeah, it works or it doesn't work. We're starting to move towards production-ready machines, so machines that are on the shop floor, and we have a lot of industries that are already doing this, and I'm not going to try and hide that, but you have machines on the shop floor. They're producing in both high volume and in low volume, depending on the different parts, and producing serial production in that case there. As I said earlier on, our materials unlock our applications. This is the next big growth enabler there, that we have materials now that are able to compete with our traditional materials. We're able to use them in different places, and that opens up that application space. And when you allow more industries to get involved in technology, naturally it's going to grow, as you know. The technology is advanced. We've got much quicker machines, and costs are generally quite low. So you can pick up a 3D printer now for your home for 200-300 euro, and then for business as well. The price isn't that much bigger. It's a much quicker technology. You're talking about having prints off in a matter of hours instead of waiting for days and stuff like that. For certain parts, which has become massive. And then a big one that's we've seen a massive growth of this over COVID, and we continue to see it now with different, challenges that have happened across the world but our supply chain and this idea of distributed manufacturing. So be able to produce components on demand and locally. So if you have a factory and you're a big multinational, big factories across the world, and you might have one that looks after the spare parts for a certain line. And if something goes wrong, you have to order a part in from there. But what happens if you have, a supply chain crisis that happened during COVID, or you have the ship that blocks the Suez Canal, or you have the issues that are going over now in the Middle East at the moment, and you can't get those parts there. So can you have a way of being able to have a digital library? So an online system where you go up, download your file, and print it on the line. And we've seen success stories of this across different industries. One of the big ones was Heineken over in the Netherlands. They put a printer at the end of each of their bottling lines, and their operators were able to walk up and down the line. When they saw something at stages of failure or starting to break or whatever, they just printed the part. And then by the time it had failed or broke, or next time the line was down that they had a chance to fix it, picked the part off the printer or off the 3D printer and went and made the change. So much easier than having to go, I need to ring that part in, or I need to make sure I have a spare part in the stores, or whatever the case may be. Ireland's growth then. So we're quite a big global leader in terms of additive manufacturing applications, and we've quite a big market ourselves in Ireland. So in 2024, it was estimated to be about 1.2 billion, and we're expecting that to grow to about 6 billion US dollars again by 2032. So quite a big growth level in there. We're slightly above the global additive rates when you look at countries by country, and it is on the industrial space that we're growing that. So we have industries within Ireland that are using this technology to produce end-use customer parts for different applications. Um, generally Ireland's known for its high-value manufacturing industries, medical devices, healthcare, and we've also got quite a strong national infrastructure that supports this. So we have research centres like IMR, Irish Manufacturing Research, and IFORM. They're there to assist companies and try and get them off the ground and de-risk these technologies and hopefully make it a little bit more successful. The picture you see there of the house, so that's up in Dundalk. So that's Ireland's first 3D printed house, and it's debatably one of the first in the world that has been printed. And these are now offices for people, but they did print a series of tree houses that went to social housing project up there by a company. So they have people living in them. They are useful, and again, it maybe starts to address some of the issues we're seeing with housing crisis and stuff like that. So we're able to pull this technology in, hopefully for the better good, and try and make a little bit of an advantage in that case. I think it's important that we look at how AI is affecting this whole thing, because it's kind of we see it everywhere and we use it everywhere. So, or most people are using it everywhere, or are taking advantage of it where we can. And Additive has been kind of using it to a degree for quite a while. So we've a process called generative design where we take a series of inputs for, load conditions, material properties, manufacturing processes, and we hand off this information to an AI and a set of algorithms, and it goes and produces designs that meets that criteria, which is really, really nice, and it opens up our design space. And it means that instead of an engineer producing one, two, three different designs, they're able to produce hundreds of different designs that are validated to meet the requirements that you expect in that case. We'll start to see AI being used in closed loop process control to try and minimize part to part variability. And again, when we start to get this sort of stuff figured out, it'll open up the space even further. And then simplify how we qualify different components. So having all this data and information that's there to say that this part was produced the same as every other part that we've produced. One of the big areas that is certainly going to become open to with additive is this autonomous additive manufacturing. So you give some sort of AI bot or some sort of system an intent, what you're looking for, and it goes off and does the rest and produces a component for you. A little bit scary, but we can see massive areas where that could be useful for us, especially when we're able to design or explain or detail out how we expect something to be designed or how we expect something to function even, and then let the AI do what it's good at in that case there. Application space in Ireland at the minute, we've a massive range of different applications that we're using. We have our medical device companies around Cork and Galway and Limerick and Tipperary that are using this technology to produce implants and different components for different specific patients. But they're the kind of the high value guys, and they've invested a fair bit of time to make sure that they understand what the technology can and can't do. They have a process streamlined and organized to work around that, and it's fantastic. But when we have companies that are coming in and trying to figure out what can I use this for, we generally try to hit the kind of low-hanging fruit. So like jigs and fixtures and tooling and stuff like that are on, different components or different parts are really easy to go and 3D print and probably quite expensive to go and manufacture elsewhere. Because you go into a manufacturing shop and ask for one of something, your price is huge. So being able to take advantage of those kind of small economies and getting people to think and make these little designs and make little tweaks. Often the barriers to being able to go and continuously improve or make changes is that, oh, I have an idea, but I don't know how I make it. If you have a printer there with your engineers, your design team, or whatever the case may be, it becomes really easy for them to just offload it. And what we often see was company gets a printer in and they go, with a team of 5 engineers, we'll get one in. Then all of a sudden we have to get two, we have to get three because everyone's trying to use it and they're all there trying to print it. Now, whether they're printing something for work or they're printing stuff for home, that's a different story altogether. But people start to get interested in it and they go off and they start to explore different avenues that are out there. We're starting to see injection mold tooling, so short run injection mold tooling become really, really prevalent. So being able to produce small molds that fit into a larger mold pack to test and try out, is my design right before I go and sign off on that final mold tool design? So am I going to get the part I need there? It might only produce 100 or 200 parts, whatever the case may be, but it gives you a good solid idea before you go and make that massive investment for a much smaller investment, of course, than initially. There's huge applications out there, and as I said, as our materials get advanced, we start to use polymers that are infused with carbon fiber or glass fiber. It opens up the space even more, which is massive. And we start to see high temperature polymers. Our metal space, we start to move into different shape memory alloys and stuff like that, that we can really start to leverage, the technology and to be able to produce, hard facing end use, end customer use applications that have massive benefits. Our limitations to growth, high capital costs. If you want to get started, for me and you at home, not that hard. You can pick up a printer for very cheap, couple of €100, up to €1,000, whatever the case may be, and you can kind of just print, basic plastics, no issues there. For industry, if you're looking at printing metal components or whatever, you've high capital costs, and it's not just the cost of buying your 3D printer. It's all the other bits that go around it. It's the supporting equipment, it's your heat treatment you might need, it's your surface finishing you might need, it's gas that you have to have supplied, all this sort of stuff that builds up. So there is quite a large barrier there at the moment. Post-processing, again, I said it at the start when I looked at the process, people don't understand that we still do have to post-process these parts. The surface roughness on a 3D printed part isn't fantastic, so normally we're trying to improve that, especially on a metal component. And our mechanical properties, we have a high degree of anisotropy and, we have different material strengths and different orientations. We have to address that. We have to have a way of being able to do that. We have our certification and standards barriers, which I'll pass on to Barry in a couple of minutes and he'll talk more about that. But this is a big barrier because people go, well, sure, if I make my part now and it's machined and I'm able to certify and qualify that part off, do I have a comparable way to do that with my 3D printed part or my 3D printed process? And then a big one is our skills shortage. We're fairly, we have quite a high skilled workforce in Ireland, but we have a very small skilled workforce in comparison to the need that we have to produce. And we are lacking certain skills in certain areas. So this is kind of the AM workforce of the future. This is what someone that might want to work in this area needs to have or wants to have. And it all comes back to understanding the additive manufacturing process, the different materials, how it works, how do I design for it. And then it's okay for not to not use 3D printing. So there's plenty of industries out there that we've gone into and gone, you don't have anything here that we can really leverage from a 3D printing point of view. So we need to move aside or we need to step aside and go back to how you were getting that made. That's perfectly fine and we'll get to that stage and that's how it is. But being able to understand that, because the worst thing is you could just start to take a part that should be injection molded and start to 3D print it. Unless there's a big benefit there, you're just fooling everybody in that case. And then my last slide is world skills. So I'll give a quick plug and then I'll hand you back over to Barry or hand you on to Barry then. So world skills is known as the Olympics of skills. It would have traditionally been your traditional trades, your electricians, plumbers, mechanics, all that kind of stuff. In the last number of years, they've opened it up to different industries and different applications. So we have mechanical engineering CAD, we have additive manufacturing, we have a few different areas that fall under that in there. As Boric mentioned earlier on, in September we held our first national competition for additive manufacturing in the RDS, which was a great success. We had five competitors compete over 3 days in a series of different additive related tasks. So looking at CAD, designing for additive manufacturing, 3D scanning components, printing components, post-processing and all this kind of stuff. We were lucky to receive, and only in the last 15 days we got the approval that we were actually going to go to Shanghai 2026. So our winner of our national competition, Harry Green from TU Dublin, myself and himself will go over to Shanghai in September to compete on the world stage. So we'll be competing against countries across the world over 5 or 6 days at a fairly large scale. I think the RDS had about, I think it was 6,000 people through the doors over the 3 days. In Shanghai, they're expecting 24,000 people through the door every day for 5 days. So a different scale altogether, but look, we'll get there. So myself, or Harry's engaged at the moment in a load of training to get himself up to skill, get himself up to scratch to be able to compete. And yeah, we're really looking forward to being able to have Ireland over there represented. And I think it's only fitting considering how big this technology is for this country, and that we have someone representing ourselves over there. So yeah, thank you very much for your time. My email address is there. I'll take questions at the end, as Farag said. But I'll pass you back over to Barry. Thank you.
You're going to be a tough act to follow. I was looking there and trying to find some more applications because you said all the cool ones. Hardcore Technologies is brilliant. The houses they made. And what I found fascinating about it is they're actually rounded. So it's not 90-degree angles, they're rounded because you can save a lot more and it's quicker. And looking at the outside, it's rounded. When you go in, it's square. And it was printed so fast, it's so warm, and so many people are living in it now. And yeah, hopefully there's going to be some more projects like that, which will help the housing crisis because the amounts that you the amounts that of time that you save by just having the 3D printer set up on site and printing it. I mean, it was well ahead of schedule. And there's some nice videos as well on YouTube from RT News and everything. And like that, it was the first housing project in Europe. A few colleges have done it around the place as well, but it's nice to see Ireland's taking the lead. And Hardcore Technology as well are on our national committee for additive manufacturing, which is brilliant to have that expertise and expertise like you, Paul. So I'm here to talk about AM, which is additive manufacturing standards powering innovation. So additive manufacturing is different than traditional manufacturing. So with additive manufacturing, you're adding layer upon layer, and that's why it's called additive manufacturing. Whereas with traditional manufacturing, you start off with a big lump and you're cutting bits off it, so it's destructive and a lot of waste. So with AM, you're saving. And standards come into that as well, just like they do in every part of our life, which I'll come to now in a minute. But I wanted to point out for ESG and the environmental impact and everything that each new standard is linked with at least one of these UN SDG goals, which aims to transform our world. There are calls to action to end poverty, inequality, protect the planet, and ensure all people enjoy health, justice, and prosperity. So to have each new standard coming out linked with one of these goals for your ESG reporting and your environmental reporting is really strong as well. And it will help as well with researchers as well in order to show how the project can have an impact. And now to show you, usually when we talk about standards, not many people see how standards affect our lives. So we'll start off with clothing. So this morning, my young fella wanted to go to school dressed up as Batman. So I checked his clothes on it. They were CE marked, which is great. They're safe. He can, there's no strangulation hazard. They're fire retardant, and they're good. But it still wouldn't let him. He made a good argument, but still wouldn't send him off as Batman. Went down in the morning and turned on the kettle. The kettle worked. It boiled within the usual amount of time. Nothing went on fire, which is always good when you go into the kitchen. And that's down to IS 10101. So these are the national rules for electrical installation. And that's why you can come down every morning and turn on your kettle, plug something in, and walk away from it. So that's really important. And then I looked on the tank to check when I was dropping off to school. I had a little bit there, but I knew from the little bit I had in the tank that patch was to a standard. It's to ISEN 228. So I knew that would give me enough power to get into school, to hopefully get to the petrol station and get to work. So it did. And that's all down to standards. So that's the impact that people don't see of how standards affect our world. Standards. So where does NSAI come into it? So our role is to connect and facilitate. We have standards committees for absolute everything, and there's standards for everything, for ICT, advanced manufacturing, for healthcare, for energy and sustainability, for food, for construction, and following on from what Paul said about hardcore technologies and their 3D printed housing, and for services and business processes like 9001, your quality management system. And we have experts from industry, academia, government, citizens, and society. So they all would sit on an NSAI committee and they get to see European standards developed or ISO standards developed, the International Organization of Standardization, like 9001. They get to sit on these committees, they get to see all these standards, they get to use all this information because, as we all know, that knowledge and data are the new gold, and they can build upon it. Now, you don't have to be a committee member in order to use standards. When some of the additive manufacturing standards get to a draft international standard stage, you can go to a site, Your Standards USA, and you can input into draft standards. And there's a nice link there where you can go to, and there's some draft standards there for additive manufacturing that should be up there. And you can download them, you can look at them, you can even comment on them, and those comments will come through the committee. Now, what we have in as well, we're trying to have one world, one standard. So we have the likes of ASTM, ISO, and SEN. So these are 3 standards bodies. We're starting off at ASTM, which are the American standards body. America's leading the way with this. And then they're having joint groups with ISO. And these experts, because there's only so many experts in the world, are all coming together. And they are developing the standards. And then they're being adopted as a European standard, because what we want is global standards used locally worldwide. One world, one standard. We don't want conflicting standards. And all these standards are going to be looked at, and after 5 years, they will be either confirmed for another 5 years or updated or changed. So these standards are quite powerful. Now, where do standards fit into the likes of Paul and his research and all of his cutting edge and cool stuff he does? Well, what we do is we have the likes of Paul on the committee, and he's looking at all these standards. And what he's doing is he's using that knowledge, because you have top experts from a lot of the world's top additive manufacturing companies. They're flying off to some nice countries around the world because it's international standards development. They never get to see anything nice. They're put in the basement under the neon lights, and they have to come together and write a standard. So these lads are there, putting all their knowledge. Some of them are 30, even 40 years in the business. They're writing these standards, and then Paul can come along, he can read it, he can use it, and then he can say, you know what, this line needs to be changed. This isn't clear. This is how I used it. This is a way to make it better. And this is how Ireland is having an impact on these global standards, with the likes of Paul commenting and giving his more, well, I'd say 2 cents, but it's more than 2 cents that Paul gives. And that's helped building trust, and it's helping as well get from a low to the technology readiness level out there to mass market, to just giving the quality, the standard for post processing, having that in the tender, having that in the product description, and that's giving new companies not just a bit of confidence in the product at the end of the day. And that's how standards is helping to move from a low TRL to a high TRL, and why standards help bridge the gap between the research and the market. Okay, we've got people there and scales and all my nice little drawings there. Now, national AM standards. So we do have national additive manufacturing standards, but they're adopted. So what happens is these joint groups, these experts in the hotels under the neon lights, they develop the standard and then they get adopted. So it becomes an EN ISO. And then Ireland adopts it and becomes an ISEN ISO. Okay, so you look at it and it comes like this: ISO 252941, and will cost you up to €100. It gets adopted then as a European standard, and then it gets adopted by an Irish standard, and it's half the price because we are funded by the government. The government have recognized as well the power of these standards. So we don't need to make a profit from standards or cover our overheads. So we just pay ISO the royalty, it covers it. And that's how we can give you the additive manufacturing standards at a reduced price. So I think in a former life as a car salesman, and that's why I'm doing the sales piece. So there we go. Now we come to ISO PC 261. So at an international organization of standards level, they have technical committees for everything. So this is 261 committee created, and it's for additive manufacturing. The secretary is from Germany. They have published 54 standards since the committee started, and there are 15 standards under development, and there are 29 P members, which are participate members, which are countries participating in the development of these standards, and Ireland is one of them. And when it comes to voting, there's different stages that goes through. There's 6 stages. We have the same voting rights as China and as America, and our voice is heard in giving that value that it deserves, which I think is brilliant. So you have the TC there, which is the boss, and there's different meetings about twice a year. And then we have the different working groups underneath it. And these help develop the standards. So we have a work group on terminology, which I'll come to, that helps everyone speak the same. We have working group 2 on methods, processes, materials. Working group 3 on test methods. Working group 4 on design, environmental, and aerospace. So it starts off at ISO and ASTM because they're joint standards. So American ISO get together. You have the working groups, and then you have the joint groups between ISO and ASTM, and they go off and develop the nice standards. Everything is hyperlinked. So I'm going to make these standards available after it because it was painstakingly to go through and hyperlink everything. So you can click on all and see the numbers and read abstracts. Now, terminology, I think this is very important, especially for trade. You want everyone talking the same language these days. So general principles, fundamentals, and vocabulary. And for any new technology, I think this is very important that you look at the vocabulary and the fundamentals so that when you're buying something, you don't say metal melting and you don't get something else. They know that, no, it's direct energy deposition, actually. Sounds far more cooler. And then we move on. So I'm going to go through the different standards in additive manufacturing. I'm going to go to data and design. And then we'll cover processes, we'll go through materials, we'll go through personnel, and then we'll go to testing and Q&A. So start off, first of all, with my data and design. There we go. So we have TR as a technical report. This is back in 2020. So we have ISO ASTM developed the standard. We have its full standard, the number, and then we have the year it was published. So we have standards for design, functional graded additive manufacturing. We have requirements, guidelines, and recommendations. So if you click on any of these, and I'll click it there, and something will happen in the background, and I will, yes, it is safe. So it'll open the background, and then we'll go to registration of data acquired from processes, monitoring and control. So when you get to slides, you can click on any of these hyperlinks. It'll bring you to the ISO site, where it gives you the title of it. It also gives the abstract as well, so you can see what it's applicable to, what it does. You can come down and see the stage that's published in 2018. I can see about number of editions, number of pages, technical committee, and so on and so forth. And then you go to the NSAI site and buy it. Don't buy it from myself. And yeah, so that's why everything is hyperlinked for you. We have design part 1, laser-based power bed fusions of metals. We have specification for additive manufacturing file format. We have overview of data processing. We have design of metallic materials, laser-based power bed fusion of polymers, because Paul talked about all the different materials. You have polymers, you have ceramics, you have metals. We even have data optimized medical imaging data. You have a lot there. So that's just data and design. And then we move through my cool slides, materials. So we have additive manufacturing of metals, environmental health and safety, general principles for use. That is quite important. We have material extrusion-based additive manufacturing of plastic, feedstock materials, powder life cycle management, which is very, very important because if it's there for so long and it absorbs the moisture, you're not going to get that really good finish and good strong part that you wanted. You have additive manufacturing of plastic materials, process equipment. We have measured metal for characteristics, methods to characterize metal powders, feedstock materials, qualification of materials for laser bed powder fusion of parts. So again, all these for all the different materials. And again, you can look at these, click on the links, you can read the abstract. If you're a researcher, if you're working in the field, you can see, is this applicable for you? You know, is this something that you can put either in a tender if you're buying something, or is it something you're going to use and put that on the product or say it as a sales that it is to an ISO standard, you are using it. You're following all the shell statements in it, and using that standard. So it gives the end user that bit of more confidence in the end product. And they'll move on to personnel. So like that, there's qualification principles of coordinated personnel, general qualification of operators, installation, operation performance, additive manufacturing for automotive qualification principles, generic machine. And then we come to the processing. So part two, processing of equipment, direct energy deposition using wire and arc, process characteristics and performance. We have acceptance tests for laser, metal, powder bed fusion, machines for metal materials for aerospace applications. So even though you're not sending it into space, maybe it's something as well you can put on to show how strong the part is. If it's, you're going to use it, process characteristic and performance, metal powder bed fusion, process to meet critical applications. So again, Paul was saying about printing it and using it, and we're going to come to applications. This can be used in critical applications as well, which is absolutely amazing. And then you have qualification principles requirements for industrial additive manufacturing processes and production sites. So again, if you have that standard as well and you're using it, it just gives the end user that bit of confidence in the end product. So that's processes. And then there's one going back to 2015 for overview of process categories and feedstock. And that was just recently confirmed again. It's an oldie, but it's a goodie, just like me. And then we have testing and inspection. So we have TR, technical reports, non-destructive testing and evaluation, defect detection in parts. So again, really, really good if you're just going to be printing off one part and doing a batch of them. You can go in and make sure testing elevation, but there's no defects in the parts. We have test methods of determination of particle and chemical emission rates from desktop material extrusion 3D printers. Very important. And there's other ones as well that's coming down the line, harmonized standards with the machinery directive for that safety part as well. Because I think using all these materials and they're fast flowing, you do want to take into account the chemical emission rates, especially Paul was saying as well, people have these 3D printers at home, they have them maybe in small box rooms or in bedrooms. So the standard and the standards there, to help with the risk and manage it. You have additive manufacturing, round-robin testing, general guidelines. We have finished part properties, post-processing inspection and testing of parts produced by power blend fusion, requirements for purchased AM parts, again, in oldie but a goodie. And that is the testing and inspection. So in development, what is happening with these standards in development? There's about 15 in development at the moment. So we have data formats, file format supports, ecosystems and evaluation. We have common failure modes used for processing risk mapping. We have classification of imperfections in the EV parts. We have data capturing and structure for PBF LB machine log. We have design, direct energy deposition of metals. Okay, and now just to say about the cutting edge research that Paul does and the impact as well that's having on people. So Atlantic Prosthetic and Orthodontic Services and the Irishman Research Centre collaborated to develop a digital workflow for computer-aided design and additive manufacturing for transtibial. So transtibial is from the knee down, for prosthetic sockets from scanned patient data. Because when they did the scanning, you're either size 3 or 4. If you were 3.5, you'd have to wrap it. And you're not giving the patient a good quality of life. So this I think is groundbreaking, that from a scan, they can give a patient matched device to you, and they use standards in order to give that quality, give that oversight to the clinician who can sign it off. I mean, that's absolutely brilliant. And it's improving people's lives as well, giving them a better fit and a better quality of life. So in this collaboration, the standard management systems, manufacturing specifications, test methods, product specifications, all the cool standards, they were all leveraged to develop a body of evidence that allowed the clinician to sign off. So you have overview of data processing, standard supported identification of best practice for data handling. You had the geometric accuracy of a manufacturing process, the standard supported qualification of machines used to build test coupons and products. And you had The general requirements of AM parts. So again, 2017, I did say it's an oldie and a goodie, and this is why. Because it's used to support risk control activities during design, development, and process validation. We have ISO ASTM 52921, standard terminology for additive manufacturing, coordinated system test methodologies. The standard supports communication and documentation of best practices clearly and unambiguously. So standards were identified and leveraged, determined, measurable, critical to quality design that enabled innovation. Okay, and there is other applications as well that maybe are good. So where is it here? So as a kid, I got this on Christmas, the Starcom missile launcher, which I thought was cool. I found it in the attic the other day, but I lost that missile launcher probably on Christmas Day, the little red missile, and put the tie away. But recently I found that you can get the file, the Starcom missile Fox satellite. There you go. There it is there. You can buy that file, 3D print it, which, where's the camera? There, oh, see the back? There we go. I've got loads of them. So now that tie is reused, and we went off camera for a little bit to try and wrestle the 6-year-old to get the tie off it, and there's no way. He's down there shooting and using it. There's only that girl and he's tried it. But this is just, the cutting edge application, and this is kind of the everyday application that feeds into what Paul was saying about supply chain and getting the parts. It wasn't a critical part. Well, for me, 7-year-old son, it was a critical part, but not for me. And then we'll move on. So again, I'm talking about the ISEN ISO versus the BS, the British standards. So there you go, 36 plus VAT, and then the BSI 134. So this is the car salesman coming out of me. Okay, and then we have published standards. So there are a lot of published standards. Again, everything is hyperlinked, even color coded. We have green for 23. We have this gray for 2015, 17, and 20, and then the old ones. And then for 2023, we have a green one there. It's all linked there. You can see it. There's more published standards. I'm not going to read through them all. They're all linked. The slides are going to be available. Go through them all and more. And the last page, thank God. And 2026, we have the general principles for registration of data acquired from process monitoring for quality control. So 2026, this is really important. You might see it, you might need it. All the standards are there. Click on the link, read the abstract, and then buy it from the NSAI store. Resources. So on the NSAI website, we have got a sectorial study for standards in manufacturing. You can click on the link. It is a bit old now. It was done during COVID. And we have an introduction document as well to NSAI TC49 SE2 for additive manufacturing. Again, it is a small bit old, but there is information in there going through the processes, how they're created, the different working groups, the joint groups, even some of the standards that were being developed a year or two ago. You can read on it. So that is for you. And I'm going to try and put these slides up on the NSAI website for advanced manufacturing technologies. We have slides from Paul's colleagues. So when I'm asked to present and give the standards piece, Paul's colleagues come from iForm and they show the real applications that Paul was going through rather than just the standard piece. So they're up there as well. You can scan the QR code or go to nsai.ie and go standard sectors, advanced manufacturing. QR codes are cool. So just use the QR codes. Everything's better with a QR code. You can get involved. So if you want to get involved in the committee and getting all these draft standards and everything, you sign up. It's voluntary. I never ring you and ask you why you come to a committee meeting, and Paul can vouch for that. If you do comment or submit comments on standards, they're anonymized. It's Ireland's comments. If they're accepted by Paul and the colleagues in the committee, they'll go off as Ireland's comments. So the ISO police will not be ringing you at 2 or 3 in the morning. You're safe. Okay, they may be ringing me, but they won't be ringing you. So you can go in and submit comments, and don't be afraid, and give yourself a voice, especially if you're a researcher and you're using standards and you feel that they need to be improved or used. When the standard's being reviewed every 5 years, you can go on and get involved. So again, very powerful. We have an NSAI IE e-sign magazine of all of our services, so you can see standards as they develop. You can get nice success stories and nice articles as well. Okay, so in closing, standards are part of your industry. You can see standards as they develop and can be part of the standards as develops. So you can be part of the solution, which I think is brilliant. And we're here to help. Okay, so thank you very much. And any questions, I gave the info at nsai.ie, just because I came back from holidays and I already have so many emails I haven't read yet. So if you email the info at NSAI, they'll be looked at and probably given to me, and I will get to them. It may take a few days, but I'll get to them. And Paul can vouch to it. Every time he emails me, I do get back to him. So thank you very much. It's been an absolute pleasure. Thank you, Pork, for having me. Thank you, Paul Quinn from SETU. You were a tough act to follow. And thank you very, very much.
Thanks very much, guys. You know, as when you're the MC, you're always trying to be polite and have a couple of questions ready, you know, pay attention as you're going along. And I think I only have 2 pages at the moment. Uh, but it'd probably be more polite if I let some of our attendees' questions go first, right? So we've 2 questions from one individual. First off is, where can I buy a 3D printer for home use, including necessary software?
There's loads of places online, and we've a good kind of there's a good reseller network within Ireland that you can certainly go through. I won't name anybody here, but if you search 3D printing in Ireland, there's a whole host of them there. You can pay everything from a couple of €100, as I said, all the way up. Most slicing software is the software that sits between your CAD and your 3D printer is included in it. Um, and like they're very accessible. Like I have a small one here at the back of me, and I use it for messing around. And there's more and more people now that are at that stage, so it is very, very accessible. But yeah, and most of them have really good guys in there that are applications, and they'll help you out with trying to figure it out. I'm being very polite about them because I was one of them at one stage. So um, we're there to try and help, because without it starting from the ground up, people at home, people don't figure out what works, what doesn't work. They don't go into their boss and go, I have this cool tool that I can use, and then they don't go off and figure out what standards they can use and what skills they need to do. So there's massive sets there that we can drive on. But there's loads of places. Just 3D printers in Ireland, and you'll find a host of them there that you'll be able to talk to.
And adding on to that, Paul, I think a lot of the libraries now have 3D printers. So you can
Yes,
go
very good
there and
point.
get used to it and see if this is a hobby you want to get into and you like.
Yeah, no, spot on. Yeah, thanks, Barry.
Um, so there's a question on the National World Skills Competition project. Where can suggestions for project exercises in the fitting category be sent?
So yeah, so you can if you go to World Skills Ireland web page, there'll be a contact us or page in there that will go to our technical delegate for the country, and then he'll send it on to the relevant chief examiner. So whoever's in charge of fitting, or will get should get your suggestions or your comments in there. But yeah, no, feel free to do it. And they're always looking for more industry engagement and stuff like that. And I'm even going to do a little shameless plug here now. If you're in the additive industry and you want to get a little bit involved in this year's national skills competition, please reach out to me, get in touch with me, because we're without a few people that are going to be there to help, because obviously I'll be in Shanghai and there'll be a few other people out missing, so we need to grow that a little bit more. So if you're interested, please let us know, and we'd be more than happy to have a chat about it.
Um, uh, Barry, question for you from one attendee. Are there any difficulties making IEC, ISO standards that have been harmonized for various EU directives and regulations? Are there any challenges to making them available? Or?
There is, so they're being released in batches. There is a site, a website where you can go in and view them and look at them. But because there's so many, there's like 600 with the machinery directive,
Okay.
and they're always being every few months even there's more coming out, and because of machinery regulation coming in, and you've got TWO's annexes, depending on with the machinery directive or machinery regulation. So because of all that, and because there's so many directives out there and so much legislation and so many old ones, new ones, that there is a bit of a backlog, but there is a website for the harmonized standards that you can go and have a look at it. If you're having any trouble finding it, info at NSAI, you can email off and they'll give you the link. I can't remember the link from the top of my head.
Thank you. So a question from one attendee, from a college point of view, and this is probably for Paul, what's the most cost-effective way of getting into metal printing?
Uh, you need plenty of money. Let's start with that anyway. There are machines, there are processes now that are out there that are aimed at R&D and aimed at colleges and trying to get people into it. And the cost has come down significantly. Like the first machine that I worked on, PhD side of things, was I think it was 400,000 euros to get it in and installed. There's more and more machines out there now that are coming in below the 50,000 euro range, but they're still in massive money, unfortunately. And with that, there's limitations in terms of materials and build volume, and you're not really going to do anything substantial. It's going to be purely R&D work and stuff like that. But there are options out there. There is your there are other options for metals. So there's stuff like, the extrusion-based metal options that are out there, and they are far more affordable in terms of being able to get in them, but they're slightly different process. There tends to be other more downstream processing that you have to do. You may or may not be getting a fully metal part, let's say, but it is somewhat there. But it's certainly more affordable than it used to be, but it is yeah, it's still quite expensive. Your materials alone, like a kilo of titanium is like 500 euro or so, give or take. So, that's a big ask on that sort of stuff. Yeah.
A question on the tolerancing or precision of current additive manufacturing relative to traditional manufacturing, presumably subtractive, where and tolerance stacking in assemblies or geometric tolerancing, otherwise surface finish, for example, is important. So I guess I think if I interpret the question, I think is where do we compare currently? What are our capabilities currently?
Without significant work, we're still miles away. So precision machining is called precision machining for that sake. We don't have precision additive manufacturing at the moment. We'll get there. We'll work on it. And I hinted on the idea during the presentation that we're a complementary process at the minute. So we can use our technology to do all these weird and wonderful shapes and stuff like that that we've seen. And then we might need to call on a machine, milling machine or a wiry dam or whatever to give us that surface finish or that surface tolerance in the critical areas. And most industry are doing that. Aerospace have adopted that massively. They get the general shape made, and then they use your traditional process to get your mating features and your fatness and all that kind of stuff to be within your tolerance zones. But out of the machine, we're still a good bit off, and we're much better than we were this time last year. But we're still, it still takes a while to get to that level.
Okay. And so now to my 2 pages. First to yourself, Paul, if it's okay. So I suppose 2 questions. One is end customer use products other than say medtech,
Yeah.
and then what's the story in subcontract AM? Like, so I'm hearing about tool rooms buying printers and all the rest of it. Is there any of that stuff going to good use? So yeah, there's 2 questions at one time for you.
Yeah. So there's end use stuff. So the end use for different customers, industrial customers, we're seeing a lot of it in robotics, customized grippers and holders and stuff like that, and being able to make use of lighter robotic arms to do heavier payload work and stuff like that by optimizing end of tool arms. That's a big area. It's starting to creep in your high-end luxury stuff in terms of let's say customized cars or certain features. So BMW had for a while where you could go and customize the interior. Now I'm sure there was a massive price tag associated with that, but they went and printed a lot of these parts and then finished them to make them look whatever way you had them set up. But yeah, that's kind of where we're at the moment in terms of that. So as I said, a medical device and our aerospace have grabbed this and ran with it, and they've been able to make advantage of it. The rest of the industries are still catching up. We're seeing construction, as Barry highlighted, and I highlighted, it's getting there, but it's just getting people. It's like everything. It's getting people to trust that this does what is there, and that's where the standards play into it massively. But you can imagine if I give someone this weird and wonderful shape and go, that is the same as the big block of material that I originally did. As an engineer, we kind of look at it and go, oh, that's not going to be as strong, you know. So there's immediately that sense in there. Um, and then, sorry, your second question was, sorry.
Was it about, I'm hearing about machine shops and tool rooms buying printers, and I was just wondering where the contract additive manufacturing space is at, if it is at all.
Yeah, no, there's loads of different options out there. There's obviously your tool rooms that are local, that are starting to do it to maybe ease some pressure or even just to offer it out as a service. There's also then internet, like just big bodies like stuff like Xometry where you can send off a file, they give you a price within seconds, and you know you produce whatever amount of them there are. It is a big industry, and we've seen certain industries use that sort of technology or contract side of stuff to be able to, let's say they have an issue in production and they're trying to get around it and they need 100 of these parts quickly and they can use it that way. So they don't have the capability inside house. But what we've also seen is when people start to go down that route of using a contractor, they eventually just come around and start doing it in-house themselves.
Ah, okay.
Because the cost to get involved, okay, it can be expensive, yes, but it can also be quite cheap. So you know, if your application suits it, you know, the printer behind me there was 300 or 400 euro, not that hard. You could set up a load of them and print all these parts very quickly, you know, that sort of way. So, um, yeah, the contract thing is massive. We have a few contracts in Ireland, small companies, but it will be, I don't, because of how accessible it is, it will slowly die out.
I see Barry's waiting to join in on that as well there.
Yeah, I wanted to come in. I think it's great as well. The university and colleges, a lot of time they get the equipment in, but you can rent the equipment out from the colleges. It's there to be used. And
Okay.
you can also work along with the colleges, and give them what you're thinking of printed, how to do it, and use that expertise. You know, and Paul as well, he's probably, you can open him to bribery. You can get him a bottle of wine, a few bottles of wine, and a dinner out, and ask him the best way to design a piece and use all of his knowledge and the experts' knowledge from standards, and he'll make you a great piece.
Question for you, Barry. And I had no sense of the scope of the work that was going on in standards development for this space, right?
Mhm.
Yeah, I had imagined maybe you going through half a dozen standards in detail or something. That was the end of it, you kind of thing. Right? But you mentioned the committees early in the presentation.
Mhm.
Is there a link or is it based on the NSAI website where you can have visibility of the committee so you can see the various teams and what's going on around the place?
Yeah, yeah. If you go to NSCI.E and standard sectors, you can have a look at the different sectors, but it's only half it. So we have a lot of standards committees for AI, blockchain, safety machinery, but we also have small committees as well, e-committees, where an expert has a niche in a small field, get welding, something like that, and they're only interested in one standard. That's something as well. So what we can do is you can contact NSAI and say, I use the standard, it's being reviewed. I don't know, what the changes are going to be. It's going to impact my business, and we can help set you up so you can follow the changes and you can implement
Okay.
the changes in the standards.
Okay. Thank you. I think that's it for the questions. I'll hang on to the rest of my questions for another time. Um, Thank you both for the the generosity, the enthusiasm, and clearly the huge work that went into it. Um, Massive thank you for the hyperlinks. Very, yeah, that's gonna save so much time. Um, yeah, I mean, I've been aware of the space. It's over 20 years since I first got a prototype made to get it past my marketing with confidence, right? And rather than having them sign a drawing, I had them actually sign the part so that there was no confusion and that got locked away while the tool was being made, for the product, right? So, but despite the awareness, right, I've had my learning curve has had an extremely steep addition tonight, right? So thank you very, very much for that. Given all the work that's going on, it's likely that we'll be back to you again in in a while for maybe an update, if that's okay. But thanks very much and good night.
Thank you.
Thanks for it. Thank you.